Hello, everyone, and welcome to another episode of Simplifying Network Automation with NetGru. I'm your host, and following up on the live stream we had last week, we brought back Abhijit Bakale. Abhijit, thanks for joining us again. Thanks for being here. So we're going to continue the conversation on Cisco NSO. Right? We left off. You had installed NSO. You had explained how to create a directory to have it kind of like an operational directory, and we were left off at the point of starting to add devices. Is that it? And kind of
Yeah,
seeing how configuring devices with NSO works. So,
that's
welcome back. How was your week for the past
yeah.
week?
The
Everything
week
good?
was very nice. I was involved in a couple of pretty interesting activities at Pinet Labs, and apart from that, I took a personal trip to one of the destination I wanted to visit over the weekend. So that's how my week went, and I was excited since we scheduled our second part of our webinar, and this is exactly why we have joined. So, like you said, last week we discussed about the fundamentals of NSO.
Mm-hmm.
We spoke about how really NSO makes it or makes a difference when it comes to kind of making configuration changes on infrastructure devices. And we also saw a demonstration that how you can install NSO on the system. And we were just about to get started with adding a network device so that we
Mm-hmm.
can do some sort of configuration onto that via NSO, but we ran out of time. So this is exactly where we're going to pick it up from. Just to give you a glimpse, or give all of our audience who's watching us live a glimpse that NSO is an SDN controller which is used for managing different type of network infrastructure. So when we discussed in the previous session that what are the pros and cons that it brings on the table, we discussed that managing your infrastructure from a single point of touch is very important when we look at the amount of complexity which is being introduced nowadays in the IT infrastructure due to the rapid demands, and due to a lot of, I would say, SaaS applications which are being deployed by hundreds and thousands of businesses. The complexity of your IT infrastructure have increased a lot, and this is exactly why we need to look for optimized solutions or better solutions which can manage your complex infrastructure, because we cannot say that we can reduce the amount of complexity in the IT infrastructure, right? We want we have to take care of the requirements that our business side comes up with, and whenever there is a new requirement that's going to come up, it definitely is going to introduce some level of complexity. And we as network engineers are looking forward to incorporate newer solutions and better solutions so that we can manage our infrastructure in a better way possible. And NSO is one of that particular solution which is playing a vital role for specifically for service provider organizations and service provider managed infrastructure, because service providers do require a lot of customizations according to their customers' needs, and NSO takes care of that well enough. And we're going to see a demo of how that is taken care by this solution. But we're going to scratch from the basics, where we're going to start adding one device into the NSO, to the instance which we installed in the previous session, and then we're going to take it forward.
And talking about single point of configuration, right,
Yeah.
Abhijit? I mean, NSO supports high availability, right? You can have multiple. We've only installed and showed one server,
Mhm.
but you can have like a cluster of three,
Yeah.
five for high availability, right? So
Yeah. Yeah.
for folks wondering, it's not only one single point of failure, and it's only management data anyway, right? It's not actual data from your device that is going through NSO. So if NSO becomes unavailable for a certain amount of
Yeah.
time, that's all right. It just means that you cannot configure the network or make changes, but the network will still work. Traffic will still be forwarded according to the last configuration that you've had, right? So just keep that in mind. with these controllers, they are used in the management plane mostly for configuring these devices.
Yeah. I mean, yeah. So one of the so when we talk about SDN solution, number one thing, I mean, I get this question a lot whenever I do deliver trainings in consultancy for any of the SDN solutions. That what if my devices lose reachability with this particular controller? Then what? So when we look at that from one perspective, then even if you lose the connectivity with NSO, it is not going to disturb your data plane at all, because your traffic between, let's say, site A to site B does not flow via NSO, right? Your traffic is always going to go directly from point A to point B. Whenever we speak about the management plate traffic, like when you're trying to push any configuration to the network device, or when you're monitoring what's running on that particular devices, right? This is where you need to maintain an active connectivity from the controller to the infrastructure device. And so if one thing is, even if you risk it, it is not going to disturb your data plane traffic. But if you not want to like risk it at all, then this is exactly where, like you said, high availability comes to picture, that you can deploy multiple copies and servers of NSO, and then host it across, and then if one NSO instance goes down, the another one is there to take care of it. Then we also have horizontal scaling and vertical scaling. Vertical scaling is when we increase the amount of resources on which the, I mean, on the server where the NSO is hosted, because Cisco do provide you a documentation where it tells you that how much of resource in terms of compute, RAM, and storage you require for managing kind of n number of devices. And then that particular sheet will help you identify that what would be the appropriate resources for your organization when it comes to hosting and deploying your personal NSO over there, right? So that's how vertical scaling can be taken care of. But at a limit, you may say that you're running out of your physical resources. Then you can also take care of scaling your infrastructure horizontally by deploying multiple copies of them and setting up a cluster of NSO or so.
All right. Okay. So we will address that, right? As a controller,
Mhm.
HA. Let's
Yeah,
management plane configuration. Let's jump and see how we add a device into
yeah,
NSO for folks that haven't seen
yeah.
this before.
So I will quickly share my screen there.
And there we go.
Perfect.
Abhijit, can you zoom in a bit,
So,
please? It's pretty small, just
oh
a
yeah,
couple of
I will do
times.
that.
Yes.
Better? Awesome. So, in the previous session, we what we did is we basically were in my downloads directory, and there we created a couple of directories. One was NSO instance one, and the other one was NSO install. So just to summarize that, NSO install is the installation directory where we have our NSO installed. And then out of that installation directory, we created a runtime directory, which was NSO instance. So in order to power on your instance, you actually need to cd to the instance that you have created, and then you can source an environment file which is always going to be there into your NSO install. So what we need to say is source in my parent directory, which is NSO install, and then there is a file called ncsrc. What happens is, if you don't use this particular command, then you will not really be able to use the NSO related commands, right, on your terminal. For example, the command that we use to start NSO and stop NSO is ncs. The command that we use to add a new network element driver into your NSO instance is ncs setup. So all these commands will only be enabled when you source this file. Otherwise, you can actually add this particular command into your bash profile of your Linux, and you don't really need to do that every time you start a new terminal. But and then when you do that, you actually can type ncs and press tab button on your keyboard a couple of times, and you will see a list of all these commands are there, right? So To access all these commands and to be able to use this command, this piece is a bit important. Now that I'm able to use the NSO related commands. So in order to start my NSO instance, I'm simply going to say NCS and hit enter, and it is actually going to power on my NSO instance. And now that we are up, in order to log in into NSO, I'm going to use ncs cli-c-u admin command. And like we discussed in the previous session, -c means you want the console in Cisco style, and -u is the flag that we use to specify our username called admin. And in the previous session which we had last week, we couldn't really add any device. So even if you now see show devices list, we do not really have any device available there. But I will just start another console uh, and show you that we have a device up and running which I can ping at my management IP address. And I can also take an SSH of that particular device by using admin and Cisco as my credential. So if you, this is kind of a virtualized device that we have, and we have a management uh, out of band management interface connected to or bridged to my Ubuntu machine, right? And we're going to use this particular address to add that particular device in our NSO, because currently we do not have that device added in our NSO. Now, the very first thing when it comes to adding a device, you what you need to do is you actually need to jump into the config mode, and then you need to add something called an auth group. So auth group is basically a group which actually stores the credentials that can be utilized by NSO while it tries to attempt to create a connection with that particular device that you want to add. For example, when we tried creating an SSH connection with the device, we used admin and Cisco as our credentials, because these credentials are something which I have configured on my device as part of my local authentication methods when I did set up SSH on the device. Right. So we do require some sort of minimum configuration on the device in order to add that device in the NSO and start managing that via NSO. So as part of that configuration, one, I have configured the out of band management IP address on the interface. Two, I have enabled SSH. Three, I have set up a local credential by using username and password command. And I have kind of used login local command in my line VTY. So when that's nice, yeah, auth and NetGru. All right. So what I said is I have already specified this particular credentials on the device now, but we need to tell these credentials to NSO also, that NSO can use these set of credentials when it tries to take the management access of that or administrative access of that device. So how do we do that? Now this is where a few commands can be utilized. So I'm going to say devices, then specify auth group. And I love the fact that we can use tab to autocomplete the commands in the NSO console, because we are core network engineers and we love the autocomplete feature of the CLI. So devices, auth group, we can also use question marks, and then it's going to suggest us that at this particular level you can use, or you have an option to use either group or snmp group as the command. And if you say gr, let's say, and then give a question mark without the space bar, then it's going to show you what are the list of commands that completes with the alphabets called gr. But there's only one command which is group, so we're going to use that. And then you can specify the name of the group that you want. I just tried testing to create the CLI group while I was testing whether this lab is working for or not while I was preparing for this webinar. So I created that. Default is the group which NSO by default comes up with. We're going to create a group called iOS. Okay. And I'm going to hit enter. Now you can see the mode of the CLI command changes. Earlier we were in the config mode. Now we are in config group iOS mode. And within that, we're going to use a couple of commands which are going to be default map, remote user to specify what is the username. Okay,
Question mark. Let's
it
see.
should be default. Yeah, default hyphen map and a remote okay, a remote name, not remote user. So my bad. Remote name, and then specify the username which you want to use, and then default map, remote password, and then Cisco. So these are the credentials that we want to use when it comes to creating the kind of SSH connection. And once you specify this, then you can simply, but because NSO works on the candidate configuration data store, so every time we are kind of adding new configuration, we are supposed to
Abhijit,
and
can you add like an LDAP server here or like a Cisco ICE to get credentials from there dynamically, or you have to manually configure them username and password on NSO?
I
Do you
missed you,
know?
Adrian. Can you come back with your question again, please?
Yeah, so I was asking if you can integrate this with like an LDAP server or like a Cisco ICE
Oh yes, you
where it
can.
gets
Yeah,
credentials dynamically from a server where you have them stored, right? So
yeah.
you can do
You
that
you
too,
can
right?
do that. Yes. Yeah. Yeah.
Okay.
Awesome. So now I'm gonna specify that. So once since we are done defining the credentials, I'm gonna take an exit from that particular mode, and then we're back into the config mode, and now we will actually add the device. So the command that we use in order to add the device is devices, device, and then you have to specify the name for that device. So the name can be anything, and not necessarily. So it's possible that, for example, when I go back to my another terminal, we can see that the host name which I have configured for this particular device is iOS underscore R1. So you're not required to specify the same name as it is configured as the host name of the device, right? The name that you're going to specify in the database of NSO can be different than the host name which you have used for the device. So I'm going to say devices, device. Let's say here I'm going to use R1. And once I hit enter there, then this is where you can see that we have entered into config device R1 mode, and then you have to specify the details about that particular device. So I'm going to say what is the management address that you will be using to communicate with the device. So that's 10 to 55 1.101. Then we need to specify the auth group which the NSO can use in order to log in into the device. So I'll say auth group is going to be, and if I give a question mark now, you can see, you will be able to see the uh, auth group that you recently created. So that's another good part about it, that we can use autocomplete and we can use question mark to see our available options. You don't have to necessarily scroll up and then see what was the auth group I created. Oh, I forgot that. Again, come back and then go to the show commands and see what are the list of auth group. This feature is something which increases the convenience. So auth group iOS. Then we need to specify what are the SSH or how are you going to do the host key verification. So sometimes we can add the SSH keys or RSA keys onto the known host devices so that you don't really need to worry about that. But since we're in a lab environment, I'm going to say SSH host key verification set to none. And post this, we need to specify how do you really want to manage the device. So we use a command called device type, and you can see the options that you have here is CLI, then a generic, then netconf, and then SNMP. So this is where you specify that how do you want the southbound communication from NSO to the device to be. Do you want to manage this device by using CLI? So NSO uses the CLI commands or CLI language to communicate with the device. Or let's say we are managing a device which is compatible with model-driven programmability. For example, Cisco iOS XE platform devices, or let's say specifically the cloud service router virtual device, CSR 1000V or C8000s or so on. These devices are natively compatible with protocols like netconf. So if you want that communication between NSO and the device to happen over netconf, you can select that option here. But since we are adding a device which does not have netconf capabilities, so I'm going to use CLI. And another very important definition here that we need to do is specifying the NED ID. So for those of you who haven't who couldn't join us in the last week, I'm just briefing you that NED stands for Network Element Driver, and NED ID means you need to specify what is the network element driver that you want NSO to use for managing that device. So if I simplify this understanding to you, I explained in the last session that network element driver is one of the core elements of NSO, which allows NSO to manage configuration of different type of devices, irrespective of whether they're from Cisco or non-Cisco. So NSO has the capability of managing devices, let's say of Juniper, of Dell, or some other vendor. And the capability that enables NSO to be able to manage that is network element driver. So sometimes you will find out network element drivers provided by on software.cisco.com. Sometimes you might not find a network element driver for the type of device you want to manage. And if you're so dedicated to manage your infrastructure via NSO, but you do not find a network element driver available, then you are free to create your own network element driver also. However, that's a tedious task. But then, since it brings a lot of benefits on the table, an organization may wish to create their own network element drivers. So when we install NSO, we actually get few network element drivers. I will also show them if I just go to the file structure. So here in the downloads directory, you can see I had the NSO instance, which is the kind of runtime directory we have, and NSO install, which is the installation directory. So this directory is where we installed NSO. If I open that, you will be able to see that there is a directory called packages. And within that directory, there is another directory called nets, right? Network element drivers. And here you can see a list of network element drivers are available, which includes A10NED, AluSR, Cisco ASA CLI, Cisco iOS CLI. There are a couple of versions for them. Then Cisco iOS XR CLI, Cisco NX CLI. So if you want to manage, let's say, a Nexus switch via NSO, you have to make sure that you have installed this network element driver in the NSO instance that you are using. If you do not install this network element driver, then your NSO will not be able to manage Nexus devices, right? So it is pretty crucial in order to, it is pretty crucial for us to identify the appropriate network element driver and then install that. Because one of the capabilities which we talked about was intent based networking. So whenever you communicate your intent to NSO, let's say you want to configure a loopback interface on let's say multiple devices. Now couple of devices that you have in the NSO, which NSO is managing, is let's say iOS devices. Then few other devices are iOS XR devices, and then you have XC devices and Nexus devices. You just want to communicate to your NSO that I want to configure loopback interface on all these devices. But the commands that will be used, or the CLI commands that will be used on all these different devices, do not really match. The command that I can use to create a loopback interface on an iOS device is different than a command that I'll have to use to achieve the same on maybe the Nexus switch or iOS XR. So when you tell NSO, or when you add devices by specifying the appropriate network element driver, you can just tell NSO that you want to create a loopback interface on this device, and NSO internally will utilize these different network element drivers to know that what are the commands that NSO has to use to create the required command set. And then all you have to do is just commit that. So you don't necessarily need to kind of struggle for defining different types of commands. NSO, with the help of network element driver, will be able to do so. And this is not the only thing that a network element driver does. There's a bunch of things, but this is just a beginner's understanding that I told you, so that you can understand the importance of network element drivers. Any thoughts, Adrian, on this?
Yeah, and these 10 come in by default, right? You've just
Yeah,
installed that NSO, you instantiated an instance of it, a running instance, and you got these 10 NEDs over there by
yeah,
default. So you don't need to do anything special to
yeah,
get these ones.
yeah,
But
correct.
like Abhijit was saying, if you want to manage other types of devices besides this 10, then you need to manually either download that NAD package from software.cisco.com or develop it yourself or getting from GitHub from somebody that you trust that has developed a good NAD and place it in this folder so that it becomes available to your NSO instance.
Yeah, correct. So finding out the appropriate network element driver. Well, if you find that there is a net, this is an extreme level of happiness you would experience. Otherwise, you'll have to create your own network element driver if you are looking forward to manage some other type of infrastructure. So yeah, like Saurabh is saying, a net can be a real help in multi-vendor based network. That's correct. And so what we have did is in the last time when we installed this network element driver, we installed the Cisco iOS CLI 3.0 network element. So if I go back to the folder or directory which we have created for installing the NSO, here there is a folder called packages, and within packages you will find out that Cisco iOS CLI 3.0 is available there. And there is also a service package. We'll talk about this when we speak about services. But for now, you can see that this particular network element driver is something which I already have installed. So this is the one which you're going to use. I'm going to go back to my CLI. And when I give a question mark here, I need to specify what is the network element driver I want to use. So I'll say network net ID, give a question mark, and you will see Cisco iOS CLI 3.0. And I'm going to use Cisco iOS CLI 3.0. And then you need to specify what is the protocol, the remote management protocol that you want to use to communicate with this device. SSH and Telnet are a couple of options that you have here. So I'm going to say SSH, of course, and hit enter.
Wow, Telnet still shows up.
It's still there.
Surprised. Wow.
Okay, so now one last thing that we need to specify here is by default, whenever we add a device into NSO, then it is in southbound lock state, which means we cannot really make configuration changes on the devices. So if you want that southbound communication to be unlocked, so that you can manage and do configuration changes on that device, you have to say state admin state unlocked, and this will allow you to make configuration changes on the device. And after you use all these commands, so if I go to the root level of that in the config mode and use show configuration command, it will actually show you that these are the commands that we have used. This is some default configuration that it adds into the CDB configuration database. But yeah, these are the commands that we specified. And if you think you're good, you can simply say commit. And once you commit that, you will be able to see the device in here that you have added a new device. But if you look at the running configuration of NSO, you need to now whenever I run a command called show running config, you will see a lot of configuration. You will see loopback service, authentication, AAA devices, and in devices you have to actually find that there will be something called devices device R1, and then this is the configuration. And within the config tag, you will find out what is the configuration that's there for that specific device. But this is of course not the configuration which is present on the actual device. For example, if I go back to my device's CLI and create an SSH session with that device, you will find out when I say show running config, there is a whole lot of configuration by default configuration, which include version, host name, and a lot of other things, right? Username, the interface configurations, and everything. But we don't see this configuration at all on the database here. So whenever you're going to add your device for the first time, you actually need to pull the running configuration from that target device to your NSO's configuration database. Otherwise, there's going to be a config diff, right? So the configuration that's there in the configuration database of NSO does not match with what's running on the actual device. So in order to match this, because without this, you will not really be able to do any configuration on the device via NSO. So if you want to match that, you have to use a command called devices, then specify a device and the name of the device, which is R1, and use a command called sync from. This command will allow, this command is going to contact to NSO and then pull the configuration. And it says the result is true. So it actually communicated with your device and then pulled the running configuration that's there on the device. And now if I say show running configuration devices device R1, you can see under the config section, you can see a whole lot of config, which is the actual running configuration. And then NSO gives you the ability to check whether the configuration matches from the local database to the actual running config or not. For example, I can simply say devices device R1 and use a command called check sync. So it checks whether the configurations on both the CDB and the device are in sync or not,
Mm-hmm.
right? And if you feel, now here's one of the best capabilities of NSO, which I love. Let's say that I'm doing some configuration change on the device from NSO. So what I would do is I'm going to go to my config mode. Now here you can see we have a single config section there. Then I'm going to jump into my devices config. So this config mode is NSO's config mode. Then I'm going to say devices, device, specify R1, and then jump into the config mode of that device. So now we have config. When we say config, it means that we are trying to manage a configuration of some specific device. And this is where we can start defining our CLI command. So let's say I want to configure a loopback interface. I'll say interface loopback 101, and then specify an IP address, uh, maybe 192.168.101.1, along with the few, let's say, subnet mask. And then I'll use description Cisco DevNet is real game. And
Nice.
okay, no shutdown. Now this is the configuration which I want to push. I'm sorry, I mistakenly I pressed a space bar, so it gave me a list of all the commands that's there. Okay, so this is the configuration which we want to push. Now, if I want to push the config, currently your device might not have that configuration at all. So now if I try to connect with that, you can see that the loopback configuration is not present on the actual device yet. So if you want to make this configuration change, you have to actually say commit. And not necessarily, so this is basically a feature that we get in boxes like iOS XR, right? Candidate data store, which allows you rollback capabilities and others. So your device does not necessarily need to support the candidate data store if you want to get that commit feature. Like our iOS device do not require us to commit any configuration, but in NSO we are committing it and then the change is coming up. And now if I see show IP interface brief on the actual device, you can see loopback 101 just got configured. So this change, when I say show running configuration on the actual device, you will see under the configuration that we have interface loopback 101. And in our NSO, when I say do show running configuration, devices, device R1 config, you can see that the interface configuration or loopback configuration will be there also.
What
And
if you have a feature interface already configured, right? And you're trying to push, basically overwrite the
Mhm.
config on the device. What
This is
happens then?
exactly what I'm going to demonstrate now.
Okay.
So, and that's my favorite part. So sometimes what happen is the infrastructure that we're talking about, right? Not necessarily you're the only administrator who is doing configuration changes, and you have spent uh, a good amount of time, ignored a movie night with your girlfriend or boyfriend, and then spend a good amount of time building up a configuration which you think that you can push tomorrow in the production environment. You did that, but someone else came after you pushed the config, they made changes, and now the config doesn't really work as expected. So what if I directly, to demonstrate the same scenario, let's say what if I directly go into the CLI of my device, because some administrator might have that privilege of doing so, and you, let's say you have not implemented rollback access, role based access, or other things which would restrict someone from doing such sort of configuration changes. But let's say we go into config mode, and then I manually say no interface loopback 101. Now, what happens is, if I see in the actual device, there is no loopback 101 now. The loopback is gone. But if I go back to my NSO CDB, and if I say do show running devices, device R1 config, and then see, the loopback is still present into the config data. So according to NSO, your device actually has loopback, but the loopback does not exist on that device. So what do you do now? When we look at NSO, we can definitely configure a whole lot of other things like alarms and all that stuff, which would notify your user that there's a config change on a scheduled interval also. But now what happens is, let's say there is a new requirement that comes up to me, and I understand that okay, this is something which is a new thing which we need to, let's say creating a new loopback is a requirement. So I'll go and, assuming that everything is working properly, I might say interface loopback 201 now, along with, oh, sorry. Okay, so we need to go to devices, device R1 config, and then say interface loopback 201, and then say IP address 192.168.201.1, along with the subnet mask, and maybe description. DevNet is actually great. And say no shutdown. And now when I try to commit that, there. You see it says aborted network element driver, device R1 is out of sync. What does this mean is the configuration that's there in your config database, or CDB, what we call it as, is not same as of the actual config that is running. So your device is out of sync. Now you have two choices. Another thing what you can do is you can say, so for now I will just terminate this commit. What I can do is I can say devices device R1 check sync, and it
It's
will
gonna
tell
be
you,
out of sync.
yeah, it's going to be out of sync. You can see result is out of sync. It actually compares the hashes, and then you're going to see different hashes. That's why it's not matching. And the best part is you can actually see what's the difference in the config. So I can say devices device R1 config, oh sorry, R1, and then I think there is a command called compare config. So I can say compare config, hit enter, and it will tell you what is the configuration that is not matching. And in production environment, I have seen network engineers spending a good amount of time figuring out what's not matching. So
Mm-hmm.
this feature kind of is a very good capability that will save a bunch lot of time for engineers who spend time identifying the mistake that's there in the config. So it's like your CDB acts as the golden template, and or configuration database or configuration that's defined in the NSO acts as the golden template. And no matter what configuration is running on your actual device, if you think there is something broken out, you will quickly be able to find out that what's there on the device and what's there on the CDB and what's the difference in that. So the minus I would say marks here signify that these commands are not missing. I mean, are missing on the actual device. They are there in the CDB, but this does not exist in the actual device, which points out to something like so you have two choices here. One is you can update your configuration database, which means the configuration that's stored in the CDB with the device's config, by pulling the configuration from the device to your CDB. This is an operation which we call as sync from, right? And then there is another operation called sync to, which means you update the running configuration to match the configuration defined in your golden template or golden config or CDB. So let's say the loopback configuration is something that we need on the device. Someone might have mistakenly deleted that. So am I supposed to do the configuration again? Like this is just a four CLI commands, but in actual it may be 10 or 50 or 100 liner commands or a whole lot of configuration that might be missing on the device. So the only thing that you need to do is device R1 sync to, and hit enter.
And it's gonna go and sync the
Yeah.
device, connect to it, put back that loopback 101 interface, and it's gonna show up magically. So even in cases where you replace completely a device, right? Like you said, Abhijit, you
Hmm.
have the whole config missing. You did an
Yeah.
RMA and you bring in the new device. Instead
Hmm.
of going and copy pasting line by line,
Yeah.
you just go into NSO and say, okay, sync to device, this whole config could be 50 lines of config, could be 5,000, right?
Yeah. Exactly.
That automatically pushes and your device comes back online within
Yeah.
seconds
And
with the
not
right config.
necessarily this is only the config difference or the commands are missing, or sometimes it happens that the we are trying to refer to some objects, and those particular objects are having typo mistakes. For example, I created a route map with some name, but while I'm calling that on my BGP neighbor or interface, I'm using some other name. It is case sensitive, right? So you would actually be able to identify such kind of problems. And now if I go back to my CLI of the device and see show IP interface brief, you can see the loopback 101 is actually there, right? And we did not have to manually send any CLI commands on that. So this is how uh, this is how NSO is powerful. And you can see here that watching the configuration now, if I say devices, and you may have like not just one device, you may have 10 devices, 50 devices, 100 devices, which your NSO is managing. So I don't necessarily need to run the command like devices, device R1's check sync, right? I can directly say devices check sync, and it is actually going to check the configurations of, let's say, 10 devices over there, not just one, right? And if I want to update multiple devices I can perform sync to and sync from operations on all the devices. So when I say devices check sync, it actually performs the check sync operation on all the devices that's there in the list of NSO. Although it's different thing that we only have one device in our NSO right now, but if you had multiple devices, it would have configured, or it would have performed the check sync operation on all the devices that you have. And when I say show running configuration for the device, you can see that the loopback configuration, of course, is going to be there as it is. But if you would have done sync from instead of sync to, then this configuration would not have existed here. It would have been wiped out because you chose to actually update your CDB, update your configuration database of NSO with the actual configuration that's there on the running config. So both of these choices are available to you. And the way how CDB or configuration database stores this configuration into the local database is something that you can view not just from the CLI perspective, but from different aspect also. For example, let's say I am saying I want to push a configuration. So I would say in config interface, let's say loopback 200, Okay, so we need to be in devices,
Device config,
R1
yeah.
config. Yeah. What's
And
that?
Packet Chaos is asking on X, is this session recorded? Yes, it is. So you can review it. You can see it on
Mhm.
YouTube, on X, on LinkedIn. It's recorded.
So when I say interface, loop back 200, and then IP address 192.168.200.1 along with the subnet mask, description, hey jock, no shutdown, and then say top. And now there are multiple ways of how you can see this configuration. So I'll say show config. This is gonna show me my drive run. I mean my dry run. That these are the commands which gonna be pushed. Then I would say commit dry run, and if I give a question mark, you can use a command called out format to actually see a structured way of how configuration really is, what really looks like. So if I just say commit dry run, it's gonna show you the way how NSO actually stores the configuration. Now, this is where the data structuring language comes into picture. And this is where model driven programmability also comes into picture, right? A lot of time what happens is when we implement automation, we actually look forward to use methods of programmatically interacting with network devices. You want to interact with your routers, switches, firewalls, and you want to automate this communication of you or your system interacting with those devices. Let's say that you use a Python's library called NetMiko. People who have already kind of gone through the DevNet Associate or have been studying DevNet Associate definitely might know that Python's NetMiko library is one of the library that we use, which allows us to create SSH connections with network devices by using Python. And when we do that, let's say by using this library, we execute the show commands to pull some output. Let's say I execute a show IP interface brief. So the very same output which we saw here, this is something which I can pull by running a Python script. Now let's say your manager or your there is a ticket which has been raised in your organization, and that ticket requires you to run a Python script or build a Python script that actually communicates with, let's say, hundreds of devices that's there, and it actually pulls out the show IP interface brief output. And you need that script to find out if there is any particular interface whose administrative state is up, but there is no IP address configured. Now, if you have such interface in your on your devices, on either of on any of your devices that's there in the inventory, this can be a security breach. So
Mm-hmm.
you want to bring in a feature that there is a script which actually triggers every night, maybe 5 a.m. in the morning or 1 a.m. in the night, and that checks against your entire inventory that if there is any device whose interface is powered on by mistake and there is no IP configured, then you need to trigger an action to shut down that interface. So if this kind of flow needs to be built, you actually have to make your device understand this data that you are trying to pull from the device. So when you use libraries like NetMiko is just going to pull out an output from the device, and then it's going to show that data to you. Of course, there are other ways like using regular expressions or bringing in other libraries like NTC templates and all, which may convert this configuration into structured data. But if you natively bring in, if you natively interact with your device by using programming and then bring out this output, this is just a raw output for your device. So you can make your device. I'm saying that. So there are these layers, right? You are a human, you understand CLI. There is a device who understands CLI, and in the middle layer there is a system which you're using to interact with that device. So that system, like your Ubuntu machine, your Windows machine, any machine that you're using, any jump host that you're using, that machine do not understand what CLI is. You understand that, the device understands that, but the machine does not understand that. So machine understands structured data, for example, XML, JSON, or so on. So When you need this full blown automation or the closed loop automation to be implemented, you actually need to use data structuring language to actually exchange data. And model driven programmability actually use this concept. So whenever we use protocols like netconf and restconf, you actually communicate with the devices and send configuration or receive configuration, retrieve configuration, which is written in XML or JSON, right? So that your machine can understand that configuration and it can take decisions and trigger operations on your behalf. And this is exactly what NSO also uses. So the whole point of me explaining this is, you when you say commit dry run, you can see the configuration is actually structured, and the syntax looks somewhat like JSON. It's not actually JSON, but you can see that the parent children relationship here, that
Mm-hmm.
in devices you have device R1, and then within that device you have config mode, within config you have interface, within interface you have loopback, within that you have a description, then you have IP. So you see description and IP, they're like brothers, or because their levels of indentation are same, but description and IP, both of them are child or children to loopback to 100. So you can, this helps you to understand the structure. And I use this particular I used to read configurations here to fine tune my knowledge about how data structuring language works back when I was studying devnet and all that. And not only this, what it does, so network element drivers are tightly also integrated with Yang data models, right? Yang data
Mm-hmm.
models work as, I would say, data modeling languages, so that they can actually enforce rules of how configuration needs to be written. And when you look at that, thanks, Shannon. Shannon says it looks more like junk than it does Jason. Perfect. So yeah, I met Jason by the way. And oh, the description was intentional. I saw Jock joining, so that's why I use a Jock. All right. So what I was saying is, this is not the only way how you can see this config. I can say commit dry run out format, and there, if I give a question mark, you have an option to see this as
In
XML file.
XML, nice.
So when I say XML, you can see this whole structure written according to the Yang data model that the network element driver uses. So the capability which we were talking about, Adrian, you can also emphasize on this if you have any inputs. So the capability that we were talking about, that network element driver allows NSO to create CLI commands irrespective of which platform you're using it for. Right. So for example, if you tell NSO to configure loopback on 4 devices, and if all these 4 devices are of different platform or different operating systems, by using network element driver, NSO will be able to define the loopback creation commands for each of that device. And it does that because each network element driver uses its own Yang data model, and it knows that what exactly should be used as the CLI commands. And you can see it here, that this is how the configuration is structured in XML. Adrian, you'd like to say anything about
Yeah,
this?
I mean, this is so helpful and so important, as especially if you start working with ANSI client and you're starting to configure devices using netconf, right? This is going to be so important for you to figure out XML, and it's not straightforward. It's going to take a bit of trial and error, but using something like NSO, right, that just outputs whatever config you want in XML, it's going to make it so much easier for you just to take this and dump it into a payload in ANSI client and
Yeah,
use ANSI client instead of NetMiko. ANSI client is another Python library that you
yeah,
use to configure devices over netconf instead of
yeah,
SSH with NetMiko, right? So that's just, yes, this is extremely helpful because as you start working with Yang data models, you'll see that it's a bit of a learning curve and you need to
yeah,
go through all the steps. So using something like this is going to be very helpful
yeah.
as you will start working with XML for sure.
Yeah, and the tags that you see here, that for example over here you see devices, and then within that you have device, and then you have name of the device, then you have config tag for that device, then interface and loopback and all that. So all of these, like, there should be a name tag to highlight the name of the device. then there should be a config tag. Within that, there should be interface. All these tags comes from the definitions which are done in the Yang data models of this particular network element driver. So the fact that we were talking about, that if you desire to manage a device whose network element driver is not present, and then you would be willing to create your own network element driver, uh, this is exactly where your focus should be. If you do not know how to create and write data models, then you would struggle creating a network element driver. But if you know how to create Yang data models and how to really work with data modeling of the configuration definitions, then you would be able to pull it off, right, Adrian?
Yes, definitely. And if you're getting started with NEDs, I mean, there's always documentation on developer.cisco.com.
Yeah,
Cisco NSO is going to show you and we didn't even touch the API yet, but on how to actually start developing your own NEDs. And now, before we're running out of time again here,
yeah,
Abhijit, and I wanted to just touch upon services, right? Because
mhm,
we've talked about it. So where the services come into the picture, right? I want to configure layer three, MPLS
yeah,
VPNs, for
yeah,
example, right? So that is a type of service that touches multiple devices at the same time, right? So there's a P, like a provider edge, customer edge type of device. So they have
yeah,
different roles in this massive service
yeah,
that is, for example, layer three MPLS VPN. So how does NSO help you with that type of situation when you have a service spanning a whole network, right, with
yeah,
different devices having different roles? Can you tell us a bit about
yeah.
that before we wrap up? Because this is a big conversation.
This is a big issue, but I will try to wrap it up and encapsulate it in a very simple understanding. So let's say when you work at service provider infrastructure specifically, then your customers come up to you with a lot of requirements, and this is more about customizations. For example, let's say that you have a pool of IP addresses available in your organizations, and then you want to allocate a pool of IP address to some customer, like customer A, and then another pool of IP address to customer B, or so on. Whenever it is possible that your network engineer who's working in your team might end up configuring, let's say, a pool of IP address to customer B, but that was supposed to be for customer A. So whenever you do interact with network devices, the network device is just going to figure out that whether the network engineer is submitting a correct IPv4 address or an IPv6 address or not. If it is syntactically correct, then the device is simply going to accept that IP address. And then maybe your network will go down, and then you'll have to troubleshoot it there and so on. So, in order to, I would say, define every single detail related to what configuration or what level of configuration you want to push, this is where services comes up into picture. With services, you can actually define your own XML sets and your Yang data models, and then you can bind them together in order to help you manage the configurations and deploy the configurations, complex configurations, I would say, in a better way possible. So what I did is, although we're running short of time, I already have created a service package, and I told you that the name of the
Was that the
service
loopback
package
service? Yeah.
is loopback service. Yeah. So one of the very thing which I define in this. So what I'll do is, I'm simply gonna go to the enable mode. So I'll just terminate this configuration. If I say, what I'll do is I'll just run a command called packages reload. So whenever you define a new service package or create a new service, you have to use this command called packages reload. NSO in the background is going to scan this packages folder and find out if there is any new package defined. If you Now, this particular service, loopback service, actually enables a new command in your CLI called loopback service. So rather than that, if I go to config mode and say loopback service, there you go. Or if I just say loopback and give a question mark, you can see this is kind of a command. It says create new loopback interface via service. And what it does is it basically allows, so by using this command, I will be able to say, I want to configure a loopback interface. I want to do that in configuration. Let's say I will say the name of that particular loopback. I want to give it for customer A, okay, or whatever, customer A branch 1, customer B branch, or whatever you want to use that. So customer A, and then it will I have defined, so these are the commands which I have defined that should be there as part of my service. So I want to configure a command called device, which is where you're going to specify the router's name on which loopback configuration needs to be done. So I'll say device, and then since we only have one of the device, I'll say R1. Within that, you see, this is where it plays a very interesting role. So it says that you need to specify the interface IP address for that loopback, the name of the interface. So I would say interface name and give a question mark. It says I can only use interfaces from 1100 to 1199. Can you have this particular thing natively on your device? No, right? Because if you are just going to go to the CLI of the device and say interface loopback and give a question mark, you can put down any number from 1 to 10,000, whatever you want. If you want, you can configure loopback 1. If you want, you can configure loopback 100, 1000, whatever it is. But that customer, that organization has been provisioned to only use loopbacks. And this is not just loopback, it can be VPNs, it can be BGPAS numbers, it can be whatever you want. So you want to restrict that particular connection or configuration, that device, from being configured with the loopback of a specific range of 1100 to 1199. So I can say there that I'm using 1100, and then question mark, I will say interface IP. Sorry. And there also you can see it only allows you to use a valid range of 1000 x dot x to 10199 x. I cannot use any IP outside of that particular. So all these definitions actually happens in the background Yang data model. So this is kind of the code block of how you define the loopback service. If I just zoom it in, you will see that this is the folder. I have opened the same folder which I showed you there in my kind of files application. And in the SRC, I have a Yang data model. And within that Yang data model, here I have specified that whenever you create an interface, or whenever you accept the interface name value from the user, the range of that particular interface name has to be between 1100 to 1199. Then I also have used regular expressions here, that whenever a user submit a value for int IP, it has to be between 10, 1. So this is for the second octet, that the first character of the second octet has to be 1. Then the second character can be anything between 0 to 9. The third character between anything between 0 to 9. This makes user to be able to use anything from 100 to 199. And then the third octet and the fourth octet, right, which can be anything between 0 to 9. So 0 to 9 plus, so x dot x. And then to commands, I can also add so when I was on my terminal, when I use question mark, it gives me the information, right? So for int IP, you can use valid IP range from this description is something which I also define in my Yang data model, right, by using tailf info. And then
Nice.
I can specify mandatory true, so user cannot skip this configuration. User have to provide this field, otherwise user would not be able to commit that config. And then you can see for description, I didn't put any condition. User can use any. So I said type is the data type of the data is simply string, right?
But it's mandatory to have a description.
Thanks, John. So yeah, this is basically a small way to see the power of how services. So services allows you to customize any level of configuration because it allows you to use Yang data models and things like that. And with that, you can take your golden templates and golden configurations to any level. Although this is a big topic, I would say, if I just keep on talking about that, I may talk about just about services for like 8 hours, and still we will have much more to talk about that. But to simplify this, services or defining services in NSO allows you to fine tune and allows you to gradually control what type of configuration you want to provision on the devices. So you can bring in the logic of XML, Yang, and Python together and create a full grade customized services like for L2 VPNs, L3 VPNs, for managing your BGP neighborships to your customer and whatnot, right? And that's a bit about services. Anything you'd like to add here, Adrian?
No, yeah, that's a nice short introduction on services. Like we only had like 5 minutes. Like you
We're
said,
gonna
this is
need a
a
part three of
conversation.
this.
Yes, I think we will. So, but today, thanks so much, Abhijit. Right, we're a bit over time here, but we've covered adding devices. We've added only one. I know you had a couple extra ones, like you had an R2 and R3,
Yeah, I had
right?
I had already
Um,
provisioned 3 devices, but time is short.
yes, so we showed you how to provision a device, right? How to configure it, how to sync the config to and from the device, right? How to make sure that if there's any changes happening kind of out of band on the device, you can still push the config, your golden config from NSO back to the device and sync to, right? So you can always have in your NSO database your golden config of all your infrastructure. You can after that see outputs of config in different formats, right? You have CLI, you have XML, right, within NSO itself. So that's going to help you a lot as you start working with NC client, with NetMiko. We kind of looking at Python and using Python to automate all these configurations. We've also had a quick conversation about services, and you showed us a loopback service, how you created it. Do you have that actually on a GitHub
Oh
repo
yeah,
somewhere? Oh, you
yeah.
do?
I
Okay,
actually
folks.
took
So,
that from developer.cisco.com.
oh,
So
okay. So
yeah,
that,
I would
yes,
however put a repo of that.
that's the point. I briefly mentioned it, but developer.cisco.com/NSO. It's a fantastic dev center, by the way. There's documentation over there on the API. We didn't even touch the API of NSO. You can
Yeah.
automate all of these things that we've showed you here that Abhijit was doing on the CLI. You can do that programmatically. So if you want to have added, 5,000 devices or 10,000, you won't necessarily do it manually on the CLI, but you can automate that step of adding your devices into NSO. There's also learning labs. There's a sandbox, like you were saying. So you don't have your NSO instance. You don't want to run it. That's fine. We have developer sandboxes, we call them. They're available to you for free. They have devices in there, right? That you can test, run configs. We have an XC. I believe there's an XR in there too. So have different flavors of iOS devices. Um, and yeah, fantastic session. Thank you so much, Abhijit, for doing this. We had a question around certifications. We didn't really touch upon that. Briefly answering to Fernando, do you recommend study to obtain Cisco Diamond certification after Cisco CCNA certificate? I mean, yes, I do recommend it. Fernando, a short answer. If you're looking into, right, you've studied, you've got your CCNA, you know your networking basics, right? A fantastic follow up to that one would be definitely the Devon Associate, where you kind of start applying automation technology to the knowledge that you've gathered in CCNA, right? So you start looking at Python and how you use that to kind of automate the tasks, the configuration tasks that you've learned about in CCNA. So you've learned about routing and switching and how to configure and manage a couple of devices. With the DevNet certification, you take that to like large infrastructure, right? So it's gonna give you the option of configuring thousands of devices at the same time, hundreds of thousands, right? So it's really bringing the skill to your knowledge, to your fundamental knowledge that you've got with CCNA. Abhijit, what do you think about that? And you've done even the Devon expert, right? So you went all the way. You've be you
Yeah,
you've
I also
challenged
strongly
yourself.
recommend. So when anyone studies CCNA, that gives them an idea about how network works and how the communication works with layer 2 protocols, layer 3 protocols. And now that Cisco also takes automation very seriously, we see the recent changes that Cisco did in its certification. So one section of even CCNA includes you to get familiar with automation. So the last section that we also see in the exam blueprint of CCNA, it covers automation at a base. But yeah, so it's like when you study CCNA, about 90% is networking and 10% is automation. When you study DevNet associate, as far as we're concerned, 10% is networking, 90% is automation. because we have people coming in from application development background. So if they are doing DevNet, they need to know about networking. And if there are network engineers coming who are doing automation, then they definitely are aware about networking, but they need to focus on the automation space. So irrespective of what level of knowledge you have in the networking, you definitely need to have some. So at least I recommend strongly to finish your CCNA if you still don't have that. Once you are done with CCNA, then you would actually be comfortable to, I mean, it makes a lot more sense to pick up network automation after that. So work on Python, then learn a programming language first, and Python is highly recommended, I would say. Then when you start learning DevNet, you will get to know about how you can interact with different types of network devices, how to use APIs and all that. And you would actually start visualizing that what kind of automation I can implement. At the basics, like with CCNA knowledge, you would probably, let's say that I want to automate the loopback configuration, OSPF config, or so on. Now, when you take your networking knowledge further, like you learn about CCNP, then you would be able to visualize even complex scenarios and tasks, that how you can automate like a complex task. And that's exactly where the real game starts.
And Fernando, I hope you're still there and you're seeing this. This was for you.
But a
I know
good
you asked
question.
it a while back. All right. So thank you so much, Abhijit, for everything. This was a fantastic session. We might look at bringing you back, talking about a bit more about services,
Yeah.
and any advanced topics. But these two sessions, I think they're fantastic introductions to NSO. And I wanted to cover NSO because it is an automation tool that's been used by service providers for many, many years now, before even Cisco acquired TLF back 10 years ago, right? So fantastic tool that
Yeah.
is very useful to have it in your toolkit as you start
Yeah.
automating, because it's very powerful, has a lot of capabilities. Um, and that's why I wanted to bring it on. And then
Yeah.
continuing on a data model discussion next week on Wednesday, we'll bring Jeremy Coho, and we're going
Wow.
to talk about, yeah, Jeremy's
King of
on next
model-driven
week.
programmability.
He is the father, I don't want to, of Yang Suite, and specifically on model-driven programmability.
Yeah.
So we'll bring Jeremy, right? We'll have new features in kind of like new updates in Yang Suite, because it's not only
Awesome.
features, but there's also going to be some new content that we have on developer.cisco.com specifically for Yang Suite. So yeah, thank you all for
Awesome.
joining today. Abhijit, as always, thank you so much, dude. This was
Thank you so much for
fantastic.
having me.
Thank you.
Can't wait to
Yeah,
have another session with you.
we'll talk about coming back and talking a bit more advanced NSO.
All right.
And folks, see you next week. Like I said, we're going to talk about Yang Suite and new updates for Yang Suite in 2025. I'll also send an invite for a reminder. I'll schedule the event today so that you folks can save it, bookmark it. But yeah, see you next week. Thanks all. Take
Thank you.
care. Abhijit, thanks again, bud.
Namaste. Thank you. Bye.
Bye, everyone.